Hello, everyone. Today we're looking at basically the sequel of the problem we looked at yesterday. Yesterday we looked at 24A, and today we're looking at 262144. And both of these are based on the game 2048, obviously. 24A and 2048 is just sound similar. And this one, 262144, is actually 2 to the 18th power. So that's actually 2 to the 7th power better than 2048 because 2048 is only 2 to the 11th. Anyways, basically you have the exact same thing as 248. The last problem, you have uh, a bunch of numbers on the line, one-dimensional instead of two-dimensional, like 2048. However, this time the numbers are only within range 1 and 40, and you're trying to find the maximum number you can get by combining adjacent identical numbers into a number one higher. So you can replace two adjacent 7 with an 8. So pause the video first and think about it yourself. Also, here's where the 262144 shows up. It's the size of n. Anyways, so for this problem, obviously we can't use the same region DP, interval DP approach we used for the gold version of this problem. So we have to do something slightly smarter. So in my comments, I have basically the whole thought process. Obviously, I couldn't solve this on myself, but I'm going to explain the solutions method in a way that may demonstrate how you could maybe think of this. And first of all, the first half is all my own gap, which is nothing related, and it's too slow and impossible to transition. However, it was like kind of good because we noticed that 40 is small and we can put in the state and then we try to transition. Anyways, that's not the correct solution. However, we then realized that two identical numbers forming into one number higher suggest that the problem is basically saying x minus 1 plus x minus 1 equals x. And there's another equation that looks a lot like that, and it's right here. 2 to the x minus 1 plus 2 to the x minus 1 is 2 to the x. And do you remember where we used that equation? Well, considering the fact that this problem is asking for probably an n log n solution or an nm solution, in which m is the range, so n times 40 solution, we can pretty naturally think of binary lifting because of this equation, and that's the technique used in LCA and ST table, by the way. So how do we do binary lifting in this? Well, at first, I just thought of maybe we can do Fij, meaning whether we can combine I and then 2 to the j after I into, oh no, the maximum number we can combine I and then 2 to the j after I into, which is the most natural approach using binary lifting. However, that's not actually going to work out because, well, we can't really transition that, right? If you think about it, we know the start point, we know the end point, and we know what it combines to, but we don't really know whether it's possible, or we can't really calculate this by transitioning like a regular DP. However, notice that we'll just really need something a little bit more innovative, some version of binary lifting that we've never thought of before. And in this case is to state Fij equals the right end of the region with left end I and value j. And that also implies whether it is possible to make the value j, because, well, j, if it's 0, then it's not possible. Anything else is possible. And how is this still binary lifting, you ask? Well, that's because this equation, because the x minus 1 plus x minus 1 is equal to x in this problem, so j is basically the 2 to the ith power in regular binary lifting, if you remember. Like, you probably get what I'm talking about at this point, because x minus 1 plus x minus 1 equals x. That's like the core of this whole problem. So if we can get to this state, we're really close, because now we can get this transition equation, which is almost the exact same as ST table, if you know how to do that. So the right end of the region starting at I and making j is, in fact, equal to the right end that if we start at I and then make j minus 1, and then start from that point and make another j minus 1, wherever that end is going to be where this region end if we make a j starting from I. You can understand that, right? So everything else is just the exact same as ST table, and if there is value, then we make it, we update the answer with that value. Okay, so hopefully after this problem, you'll know how to solve 262144. And actually, I really like this problem, not only because of how smart it is, transitioning it to a binary lifting, and also the very clever notice of x minus 1 plus x minus 1 equals x, which is really similar to 2 to the x minus 1 plus 2 to the x minus 1 equals 2 to the x, but also because the title of this problem is 2 to the 18th power, and from now on, I will know what 2 to the 18th power is exactly, and then I can like this is actually really useful when you want to do like bitmask DP because 2 to the 18th is a very popular number in bitmask DP because this is the amount that you want to do. So like 2 to the 18th times 18, and it gets you the right time complexity. Anyways, one way or the other. Thanks for watching. See you tomorrow.